Okay, so in this tutorial, I'm going to show you how to use the rule of commutation for and commutation for or in the ProofLab. So here, this proof looks like a perfect candidate for commutation because we have these two disjunctions that are exactly alike, except that over here on the left we have A and B, and down here on the left we have B and A. Also on the right over here we have A and C, and down here we have C and A. So all we want to do is switch those two around. So we could do that in 2 steps if you want to just do one application of a rule of commutation of and at a time, or you could do it all in 1 step and do both applications in just one. However, I'm going to show you how it works in the ProofLab. The ProofLab is not going to make it that easy. So what it seems like we should do is click on the line that we want to perform commutation on, and then we want to click on the rule of commutation that we want. We've got 2 down here, so you just see CM. That's how they abbreviate commutation in the ProofLab. Instead of writing COMM, and they just write CM. So that's all fine and dandy. And so we have an AND version and an OR version. So since it's an AND statement here that we want to switch around, let's just do one at a time for the moment. Let's just try to do one at a time. We need to click on the commutation of AND. So we do that. Ooh, and it gives us sort of what the rule looks like, but it doesn't give us what the rule is going to give us, using the formula we've highlighted. That's never a good sign when you get just sort of this form of the rule. But let's go ahead and try and apply it. Okay, it says premise doesn't match rule. It says the rule of commutation of and can only apply when a conjunction is selected, but the premise you selected is a disjunction, which it is. The premise as a whole is a disjunction. So as it turns out, although I allow you to do the rules of replacement, the ones that are two-way rules, I allow you to do them inside a line. The ProofLab does not. It only allows you to apply a rule, the rule of commutation, to a whole line. So for instance, I could do commutation on line 1 if I used commutation of OR. So I clicked on the line, excuse me, I clicked on the rule of commutation of OR, and now see it shows me this formula, and then it shows me what it's going to give me, which is the same formula but with the disjuncts in the opposite position. So the left disjunct turned into the right disjunct, and the right disjunct turned into the left disjunct. So if I click apply, then I'll get that disjunction on a new line. And I can do it backwards too. So I can click on a goal and then click on the rule of, again I'm going to have to do commutation of OR because my goal is a disjunction. And it says, sure, if you want to get this line 3, what's now line 3, your goal, by commutation, then what you're going to have before it is this formula here. That's what it's saying. So I can do that. And so that's my new goal. Okay, but all of that isn't really helping me get any closer to the answer to the proof, because I still have no way to switch A and B to B and A, and to switch A and C here to C and A. So what I'm going to have to do, and I'm not going to do the whole proof because it's really stupid, but I'll show you what we have to do with this. So let's erase this stuff because none of that was actually helpful. So let's reset the proof. What you have to do in order to solve this problem in the ProofLab is that you need to do a proof variant strategy. So you need to do an OR elimination proof on line 1 with line 2 as your goal. Okay, And so what you're going to have to do is you're going to have to build this disjunction from this statement. Let's just focus on that. I'm not going to do it all, but let's just focus on that. Now, normally, what you would have done before the rule of commutation is you would have taken apart A and B and created B and A. So take it apart using AND elimination, put it together using AND introduction, and then you would have just introduced the other disjunct. We don't have to do that now. Now we can do the rule of commutation on line 2. So we don't have to take it all apart and then put it all back together. We can just flip it around. So if we apply the rule of commutation of AND to line 2, see, now it's happy with it. It says, oh, you've got A and B. If you apply commutation of AND to that, you'll get B and A, which is what we want. Okay, fine. And likewise, this could be applied backwards. Let's see. Well, just in the same way that I did with the commutation of OR, I can apply it backwards. I don't really have anything that I can apply it backwards to here because I don't have any AND statements as goals. But that's fine. I'm sure you get the idea how that works from having seen me do it on OR. So I'm not going to do this whole proof because it's terrible. I mean, this next one, sure, that one's easy. That's just an OR introduction. Right. But then this one you have to do another proof variant inside this bigger proof variant. And it's ridiculous. It turns out to be like a 14-line proof for what should be 1 line. So I'm not going to ask you to do this proof, at least not in the ProofLab, because I don't like how the ProofLab treats the fact that you can't do the rule of commutation inside a line, when that's a perfectly valid thing to do, because all you're doing is exchanging one formula for another formula that's logically equivalent. Maybe they don't have that in the ProofLab because it would be hard to program. That strikes me as a thing that would be hard to do. It's like, if I said, I want to do commutation of AND on this statement, well, I'd have to specify which conjunction I want to do that on. Obviously, that's easy to do when you're just doing this on paper or on, in a Word document. You can just say, you can just do it. But here I'd have to somehow specify to the computer which AND statement I want to flip around. So I can see why that might be hard to program, and that's maybe why they don't allow it. It could be for deep philosophical reasons, I don't know. I've known other texts that had deep philosophical feelings about not using rules on parts of lines. That doesn't make any sense to me. That's how the rules of replacement work perfectly well there. Obviously, you should never use any of the one-way rules that way because they don't work that way. You're not just exchanging one formula for another that's logically equivalent. So you can't do that. But you could do it here, but they don't. So that's how it works.